to my today's session on electromagnetic field, and today I am going to discuss some harder problem on electrostatics. Myself Dr. Sayanti Chatterjee, and I am going to discuss about some harder problem of electrostatics which is very useful in the GATE and different type of examination. I am the Associate Professor of Department of Electrical and Electronics Engineering in IARE. So first problem we are thinking it is very easy. A positive charge of Q exerts a force of magnitude 0.20 Newton on another charge minus 2Q. Find the magnitude of each charge if the distance are separating on the equal to the 50 centimeter. So we have to calculate there are one charge Q, another charge is minus 2Q. The distance we have kept one another charge. I am drawing with the green one. It is 0. So this is the force between them is the 0.20 Newton. Find the magnitude of if the distance between them is the 50 centimeter. The distance between them is a 50 centimeter. So we know force is equal to Q into 2Q by first one is very easy problem. So the charge is Q into 2Q and the distance between them is the 50 square and it is 4 pi epsilon 50 square. So we can write 2Q square is equal to 4 pi epsilon into 50 square. So what is the not 50 square actually 50 centimeter. So we have to change it 50 into 10 to the power minus 2 square. 50 into 10 to the power minus 2 square is equal to, we will take only the magnitude, so 0.2 Newton. So if we solve this equation, we will get the value of the Q and Q will be in the Coulomb unit. Now the simple problem we will make it little tough. So what is the problem? Consider a point charge plus Q is placed as the origin and another charge minus 2Q is placed at a distance of 9 meter from the charge of plus Q. Determine the point between the two charges at which the potential is 0. So what is this? There is a point we have from the origin. We have placed one charge is Q, another charge is 2Q. So Q at the origin, we have placed one charge Q at the origin and another charge is minus 2Q at a distance of 9 meter from the charge. So this is the 9 meter. So what is the potential of V1? V1 is equal to, we know, 4 pi epsilon Q by 4 pi epsilon Q by 4 pi epsilon. I am thinking that at the x distance the potential is equal to 0. So this point is at origin, so the distance is x, so 1 by x. We are assuming at this distance the potential is V1. And what is the V2? V2 is the value of Q by 4 pi epsilon 2Q minus 2Q 4 pi epsilon 1 by 9 minus x. So these are the two potential for this point at the Q. Determine the point of the two charges at which the electric potential is 0. So V1 plus V2, the potential due to V1 and V2 is equal to 0. So Q by 4 pi epsilon x minus 2Q by 4 pi epsilon 1 by 9 minus x is equal to 0. So if I take the q by 4 pi epsilon x common, we can get 1 by x by 2 by 9 minus x is equal to 0. So 9 minus x minus 2x, 9 minus x minus 2x is equal to 0. So from there we can get minus 3x is equal to minus 9 and x is equal to 3. So this point x is equal to 3. So from here it is 3 meter. From here it is 6 meter. So this is the solution of the problem 2. Now we are moving to the problem 3. Consider a solid sphere of radii 5 centimeter made of a perfect dielectric conductor. If 1 million electrons are added to the sphere, these electrons will be distributed A. Uniformly over the entire volume of the sphere, B. Uniformly over the outer surface of the sphere, number C. Connected around the center of the concentrated around the center of the sphere, and D. Along the straight line passing through the center of the sphere. This question came in the GATE 2017. So what is the solution? We know the general tendency of the sphere is to stay on the outer surface of the sphere. We know the general tendency of the conductor is surface. The electric field inside a perfect conductor is 0. Hence all the charges added to the sphere will be distributed uniformly at the surface of the sphere. So what is the correct answer? Correct answer is B. The general tendency of the charge will be stay on the outer surface of the sphere. Next, we are moving to the question number 4. Actually, this question also came in the GATE 2018. In electromagnetic field, grad cross E is equal to 0. It is true or false? It is a false answer, because from the Maxwell's law we have discussed many times that the grad cross, we use the curl for a time varying field, not an electrostatic field. Here we are using the electrostatic field. So in the electrostatic field, rather than the grad, we can use the formula of the divergence in the place of the curl. Curl means grad cross E is equals to the curl of E, which is applicable for a time varying field. So grad cross E is not possible for an electrostatic field. Next question. Which of the following equation represents the Gauss law in the homogeneous isotropic medium? So which of the following equation Gauss law in isotropic medium? This is the very easy question. That is the Gauss law for a, this is nothing but the Gauss law. So Gauss law, we know grad dot D is equal to rho V, or we can write grad dot epsilon D is equal to rho V, and grad dot E is equal to rho V by epsilon. So this equation is represents for a homogeneous isotropic medium. So we are calculating the problem number 5. This question is also from the GATE 2018. The capacitance of an air-filled parallel plate capacitor is 60 picofarad. As the capacitance is a part of the electrostatics, so this question also can come in the electrostatic part. The capacitance of an air-filled parallel plate capacitor is 60 picovolt. When a dielectric slab whose thickness is half of the distance of the plate placed on one plate covering it entirely, the capacitance becomes 86 picofarad. Neglecting the fringing effects of calculate the relative permittivity of the dielectric, and we can calculate up to the 2 space. So how to calculate? First is the air-filled parallel plate capacitor. So C is equal to, what is the C? epsilon A by D, epsilon naught A by D, as the main point here is the AR field parallel plate capacitor. AR field means it is in the air, so it is the 60 picofarad. So what is the value we are getting here? It is the 60 picofarad. We got the value 60 picofarad. Now this is a parallel plate capacitor, and between the half distance d by 2 distance, we have connected in the another dielectric of epsilon r, epsilon naught. So, and these are in the AR field. So C1, what is the C1? C1 is equal to, what is the C1? C1 is equal to C by 2, because D is became half, so it is the 2C. So this value is 120 picofarad. Okay, so what is the second case? Second case, C2 is equal to epsilon naught A by D into epsilon R. So epsilon R into epsilon A by D by 2. So we can write 120 epsilon R picofarad. So we got 120 picofarad and 120 epsilon R picofarad. So these two capacitors are now as if connected in the, these two capacitors are connected in the parallel connection. So C1 C2 by C1 plus C2 is equal to 86 picofarad. So we can write 120 into 120 epsilon R by 120 plus 120 epsilon R is equal to 86. And after solving, we can get the value of the epsilon R. So this is the next question, or we can make it little easy. If we take 120 common here, so 120 epsilon R by epsilon R plus 1 is equal to 86. So 120 epsilon R minus 86 epsilon R is equal to 86. So if we solve this equation, we can get the value of the relative permittivity. Problem number 6. So 2 electric charge minus Q and 2Q are placed at 0, 0 and 6, 0 on the XY plane. The equation of the zero equipotential curve of the XY plane is, so this question, there are 4 options. We have to choose one of the options from here, and as we can check, this problem is from the GATE 2015. 2 electric charges of plus Q and minus 2Q are placed at 0, 0 and 6, 0 on the XY plane. So if we draw this problem, so what will be the answer of this problem? The answer problem is the question number 4, x plus 2 square plus y square. So how to get this? So we know that what is the potential? Potential is Q by 4 pi epsilon r. So if we draw this diagram, so what is the distance between them? One point is 2Q. Q is charged as 0, 0, 0, 0, and it is charged at the 6, 0. 6, 0 on the xy plane. So we have to calculate the distance between them is this x square plus y square. So what is the distance? 4 pi epsilon x minus, so this is the equation, Q by 4 pi epsilon x square plus y square. Next case, V for the minus 2Q. What is the 2 minus Q? 2Q, if the point is 6, so we can write 2q is equal to 4 pi epsilon. We are calculating, this is the xy. This is q, this is 2q. What is the value? It is at the 0, 0 condition. It is 2q. 2q is equal to 6, 0. Now what we have to do? We have to calculate the equation of 0. Say in the midpoint, this is the xy point, we have to calculate the potential. So for the VQ, this distance is 6. If this distance is x comma y, if the distance between these are the equipotential, means both potentials are equal. So xy means V is equal to, what is the magnitude? Magnitude is root of x square plus y square. So from here again 0, 0 means this distance is, if it is x, this distance is 6 minus x. We have solved a similar type of problem before also. So what we got? Minus 2q 4 pi epsilon x minus 6 square plus y square. So as it is an equipotential field, means both, if we add this both will come 0. So if we solve it, we can get the equation x plus 2 square plus y square is equal to 16. So equipotential field, equipotential, zero equipotential curve, equipotential field or voltage is equal to 0 means the voltage of this point is equal to 0. So you can find this type of problem came 2 times in the GATE. Next, 3-point charges, Q1 is equal to 30 nanocoulomb, Q2 is equal to 150 nanocoulomb and Q3 is equal to 70 nanocoulomb are enclosed by a surface S. What is the net flux across the surfaces? This is a very, very easy question. Though it came in the GATE in the old time, I think in 1992 or 1998. But again, it is very easy. So in a point charge, a charge is enclosed by the total number. So what is the total charge? Total charge is equal to 30 minus 150 plus 70. So it is the minus 50 nanocoulomb. So we have to calculate the surface charge is. We know from the Gauss law, what the Gauss law told? Gauss law told that the number of charge enclosed is equal to number of electric flux. So we got here minus 50 nanocoulomb is the total number of the electric flux. So answer 4 is the correct answer. Question number 8. Determine the area of a parallel plate capacitor in the air if the capacitance is 25 nanofarad and the separation between the parallel plates is 0.4 m. So this is also a very, very easy questions, that determine the area of a parallel plate capacitor in the air if the capacitance is 25 nanofarad. So capacitance is 25 nano. Nano means 10 to the power minus 9 farad. Actually, in this type of problem, the main challenge is the units. Nano is equal to 10 to the power minus 9. Micro is equal to 10 to the power minus 12. Milli is equal to 10 to the power minus 3. And pico is equal to 10 to the power minus 12. Pico is equal to, micro is equal to 10 to the power minus 6 and pico is equal to 10 to the power minus 12. So these are the main problem in the time of the GATE exam, to remember 10 to the power unit. So capacitance is equal to 25 into 10 to the power minus 9 farad. The area between the separation between them means D is equal to, separation means the distance between two parallel plate capacitors is 0.04 meter. So C is equal to epsilon A by D, and it is the capacitor is the air field, so 8 naught. So 8.854 into 10 to the power minus 12 A into D is equal to, what is the capacitance value? 25 into 10 to the power minus 9. What is the value of the D? D value is 0.04. So it is if we calculate this, we can get 10 to the power minus 9 by 8.854 into 10 to the power minus 12, and the unit will be in the meter square. So this is our problem number 8. We are moving to the problem number 9. Calculate the potential at 810 with respect to electric field E is equal to YAX plus XAY. This problem is looking like very easy, but it is one of the toughest problem. So what is the potential? We know that the potential V is equal to minus integration of E dl. So what is the dl? dl is equal to dx plus dy plus dz. From here we check there is no dz component, so we can write dx plus dy. So we can write yax plus x, or we can write dx dl is equal to dxax plus dy ay. So x ay into dot product dxax plus dy ay. In the dot product, if we similar type gives 1, in the opposite types gives 0. So we got y dx plus x dy is equal to x dy. What is the limit? Limit is the with respect to origin. Origin means 0, 0, 0. So 0 to 8, and it is 0 to 1. So this is our limit, or we can write 8 to 0 y dx plus 1 to 0 x dy. So our main aim is to change the y in terms of x. Otherwise, because y is a function of x, we cannot solve the equation. So how to write the x into y equation? From these 2 points, you can understand it is a straight line of problem. So we can use the equation of y of mx. Y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1. If we use the line equation, what we will get? Y minus y1. y1 means the first point 0 is equal to y2 1 minus 0 1, x2 8 minus 0 8, x minus x1 is 0. So y is equal to 1 8 of x. Y is equal to 1 8 by x. So x is equal to 8y. So in the place of the y, we can write 0 to 8, 1 by 8 x, 1 by 8x dx plus 1 to 0 8y dy. Now the problem becomes very easy. We can write x square, x dx is equal to x square by 2. So it is coming, so if we solve it, we can get the value x square by 2 or x square by 16, 0 to 8 minus 8 y square by 2, 1 to 0. So if we solve it, we can get the value. First one is 0. So minus 8 square by 16, one means minus 4, plus, actually minus 8 minus 2 means plus 4. So the value is coming 0 volt. So we can solve this in different types of thing, but we have to understand the main problem y dx. We cannot take y common because y is not a constant. So this is one important problem of problem 9. Now we are moving to the problem 10. Sorry, this is the problem 10. So determine whether the equations are field satisfy the Laplace equation or not. So we got what is the Laplace equation? Grad square v is equal to 0. Grad square v means del by del x, del square del x square plus del square by del y square plus del square by del z square is equal to 0. So we can write del square x square plus y square plus z square for both cases. So if we take the two value, first integration del by del x for x square is 2x plus del by del y 2y plus del by del z 2z. So if we solve it, we can get the value of the 2 plus 2 plus 2 is equal to 6, which is not equals to 0. So the first equation is doesn't satisfy the Laplace equation. Next, we will move to the next equation. What is the equation? That the v is equal to case 2, v is equal to r cos phi plus z. So what is the formula? Formula in the, this is an r cos phi z. So r cos phi z is nothing but the cylindrical component, and the cylindrical component, the formula is 1 by r del by del r into del v by del r, 1 by r square del square v by del phi square plus del square v del z square will be 0. So first we will start del square v by del z square. What is the value? Del by del z into z into 1. So first one is the constant is equal to 0. We will case the second case. 1 by r square del by del square r cos phi plus z. So we can write the first one 1 by r square del by del square r square phi. So it is coming the r of r, it will be the sine, actually this 1 by r square, it is the r sine phi. Next it will be the again minus 1, it is minus 1 by r square into r square cos phi. So answer is the cos phi. In the third case, 1 by r del by del r into r del v by del r. 1 by r del by del r of r del v by del r. So what is the value of the del v by del r in the second, in this case r cos phi will be changed into the r by r1, so it is the r cos phi. Here also 2 times r cubed. So again del by del r is nothing but the 1, so we are getting 1 by r into cos phi. So here we got minus 1 by r cos phi, 1 by r cos phi. So what is the equation will be changed? So grad dot v is will be 1 by r cos phi minus 1 by r cos phi plus 0. So it is 0. As this is equals to 0, it is a Laplace plane. So these are the today's some important problem we have discussed. So in this chapter we have discussed some harder problem from the electrostatics field, and maximum problems are from the gate. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.